In part 1 of this Scholar Slide series I spoke about literature work regarding vacuum energy utilization. In part 2 I reported my own scientific verification of vacuum energy. And now this is part 3, where I explain how to build a powerful vacuum energy motor. I have been asked rather often whether it would be possible to scale up my electrostatic rotor, which I reported in part 2, in such a way that it will produce utilizable amount of power. The answer is a clear yes, but this doesn't help very much, because the rotor would become extremely large in such case if we want to extract useful amount of power. With an electrostatic rotor of this type, of a diameter of 10 centimeters, driven by a voltage of 10 kilovolts, we could produce about 1 microwatt. Of course, we could enhance the voltage remarkably, the rotor diameter also, and we could pile up several rotors on top of each other. For all these actions, the table regards how they enhance the mechanical power output. The values are estimated according to the fundamental proportionalities of theory, where the output power P is proportional to the square of the voltage U and proportional to the square of the rotor radius R. The last line, which comes to a power output of about 100 kilowatts, would request a rotor with a radius of 10 meters. This corresponds to a diameter of 20 meters, requesting a vacuum chamber of about 40 or 50 meters of diameter. And the necessity to pile up 10 rotors on top of each other will cause a height of the vacuum chamber also of about 40 or 50 meters. Although it is possible to scale up the electrostatic rotor, it would be rather useless to build such a huge engine to produce only 100 kilowatts. This does not look like the solution of the energy problem of mankind. Thus, I regard the electrostatic rotor as a fundamental experiment of physics, and this is what it was designed to be. The practical solution, free energy for everybody, should be done differently. They do not request an electrostatic principle, but a magnetic principle. This has a rather obvious reason. An electrostatic field with a field strength as it can be made practically for technical applications of about 30 kilovolts per centimeter has an energy density of 40 joules per cubic meter. A magnetic field with a field strength practically achievable for technical applications has a field of 2 Tesla, leading to an energy density of 1.6 millionths of joule per cubic meter. The consequence is, if the energy density of the magnetic field is stronger by a factor of 40,000 than the energy density of an electrostatic field, a magnetic rotor would need less volume by a factor of 40,000. Instead of a volume of 45 times 45 times 45 cubic meters for an electrostatic rotor of 100 kilowatts, a comparable magnetic system producing 100 kilowatts would need a volume of only 1.3 times 1.3 times 1.3 cubic meters. This is a little bit more volume than a refrigerator and a powerful output of 100 kilowatts. Not to forget, these are the values for the energy density of the electrostatic and the magnetic field for practical engineering purpose. The power density is rather large because the given energy passes with the speed of light. A completely different question is the energy density of the electromagnetic zero-point waves of the quantum vacuum. This is the energy of the waves within the vacuum. I calculated this energy density in one of my publications on the basis of quantum electrodynamic considerations. The results can be traced back to fundamental constants of nature. The formula on the screen uses me as the rest mass of the electron, c as the vacuum speed of light, alpha as the constant of hyperfine structure, and h square as Planck's Wirkungsquantum divided by 2p. An energy density of 10 to the 29 joules per cubic meter makes clear that every practical setup can only extract a very small part of the zero-point energy of the quantum vacuum. This extraction is so small that the amount we take is so far away from what is available in the universe that it will hardly be noticed at all. Now we know where we have to go. The presented electrostatic rotor is a fundamental experiment of physics, but for technical applications we have to invent a magnetic rotor. This will be our way towards the clean, inexhaustible and free energy supply for everybody. Therefore, we want to focus our attention to some consideration of quantum electrodynamics regarding the propagation of the photon within electrical and magnetical fields. Here we can use the Lagrangian according to Heisenberg and Euler. This is not really understandable for laypersons, but physicists can derive the result, which is also understandable for laypersons. Photons propagate a little bit slower if a magnetic or electric field is present. Electromagnetic waves do the same. And so we postulate that not only visible light but all electromagnetic waves of the quantum vacuum follow this fundamental law described by Heisenberg. With other words, the larger an electrostatic or magnetic field strength, the slower the electromagnetic zero-point waves within the region where we have the field. We can illustrate this at the example of an electrically charged sphere, of which the field strength decreases with a square of the distance to the center of the sphere. With decreasing field strength, the speed of propagation of the zero-point waves is less reduced, so that the zero-point waves are faster if they run more distant from the center. We can apply this knowledge to the electrical field strength in the picture, where the charge Q produces an electrical field. The field is only between the charge Q and the metallic plate, because the metallic plate shields the electric field. On the right side of the metallic plate there is no field. Consequently, the reduction of the wavelength as well as the enhancement of the frequency is not to be observed on the right side of the metallic plate. This causes a difference of the zero-point waves between the left side and the right side of the plate. On the right side, the wavelength is larger, so that the waves coming from the charge Q give energy to the metallic plate. The enhancement of the energy of the zero-point waves within the field relatively to the energy of the zero-point waves without the field corresponds directly to the field's energy, so that the metallic plates absorb the field's energy when the waves are passing by. The absorption of energy causes forces which can be calculated by the use of the image charge method and Coulomb's law. So we summarize. Inside an electric or magnetic field, the zero-point waves of the vacuum are less fast than in the vacuum without field. This is the crucial point which helps us to find a possibility to take influence on the electrostatic or on the magnetic interaction between charges, respectively magnets, and this influence will allow us to convert vacuum energy. To understand this, let us regard a sphere drawn in green color, which might keep an electrical charge on its surface, but in the moment now there is not yet any electrical charge on the green sphere. The electromagnetic zero-point waves pass by without being influenced at all, because the green sphere does not yet produce any electrical field. Now we bring some electrical charge on the surface of the green sphere, and of course the electrical charge is distributed homogeneously on the surface of the green sphere. From the moment on when the surface has some electrical charge, it produces a field, and thus the zero-point waves go slower. Accordingly, the frequency of the zero-point waves is enhanced. This is illustrated in the picture, as we see the blue wave passing by when the field is present goes with reduced wavelength. The fact that the blue wave goes slower causes a gap between the blue and the red wave. The red wave has the field free speed of light, whereas the blue wave has the speed of light within the field. Due to the difference of speed, the gap between the blue wave and the red wave grows as a function of time and propagation of the waves. Now we remove the electrical charges from the sphere, and then we regard the situation somewhat later. The zero-point waves now go with the field free speed of light, what I illustrated again by the use of red color. This is the reason why the gap is growing on the right side, whereas on the left side an overlap between the red and blue wave is occurring. The red wave simply is faster and begins to overtake. And this is now the central important explanation. The gap between the red and the blue wave indicates that there are no zero-point waves of the quantum vacuum in this little range. There, the Coulomb field is missing totally. On the other hand, there is a region where we face a red and a blue wave together. This is two zero-point waves at the same moment. At this moment, the Coulomb field is doubled. Here, the gap between the red and the blue waves already has run out of our picture, but the overlap is increasing during time and propagation of the waves. Finally, we see the last moment where the slow blue wave has nearly run out of the picture, but not completely. In this moment, we see a rather large overlap between the red and the blue wave because the red wave runs faster than the blue wave. The crucial point is that we take finiteness of the speed of propagation of the interacting field into account. This is nothing very complicated, and we only follow the theory of relativity and the Lagrangian of Heisenberg and Euler. The consequence is that Coulomb's forces as well as magnetic forces, according to Biot-Savart and Lorentz, do not only depend on the position of the interacting partners, but also on their velocities. By the way, the forces of gravity have the same aspect. But they are probably too weak to make them useful for zero-point energy conversion. Physicists and engineers indeed know this, but normally they ignore it because of a simple approximation. If we regard a classical engine with a typical distance of interactions inside the engine of a few centimeters, we can calculate the time necessary for the propagation from one partner of interaction to the other one. The numerical example on the screen does this for a distance of interaction of 10 centimeters. The duration of propagation is only a fraction of a nanosecond in this case. This is so fast that physicists and engineers say it does not play a serious role when they construct practical engines. This approximation is quite good for classical engines, but due to the high speed microprocessors, the approximation is not good for the design of modern microprocessors and computers, where the signal speed in the circuit has to be taken into account even for the technology of fabrication. Although the approximation has been regarded to be good during the past centuries, it has a tremendous and fatal consequence. It circumvents our view to vacuum energy conservation. Vacuum energy conservation needs to take the finite speed of propagation of the interaction into account. And as long as we do not do this, we will not find the way how to convert vacuum energy at all. This is a small approximation with a large consequence, because we first have to overcome it before we find the way how to build vacuum energy converters. Now we understand the crucial point. This means we can now construct vacuum energy converters as we like them. We now want to regard two examples on this background which allow us to understand the importance of the finite speed of propagation of the fields of interaction. The first example describes two electrical charges which are moving towards each other in the one case and away from each other in the other case. We want to discuss both cases explicitly. The second example describes two electrical charges which are moving into some arbitrary directions relatively to each other. This has the consequence that the force of interaction even can deviate from the line connecting both partners with each other. Please have a look to two partners of interaction which we enumerate by the numbers 1 and 2. At the moment TA, partner number 1 is at the position x1a and partner number 2 is at the position x2a. This part of the interaction field emitted from partner number 1, which is running towards partner number 2 at the moment TA, is marked with a red arrow. It will reach partner number 2 at the time tc. If we would calculate the force of interaction using the static law, not taking the finite speed of propagation of the interaction into account, partner number 2 at the moment tc would feel a distance of interaction according to the green arrow. But in reality, partner number 2 at the moment tc feels a distance of interaction according to the blue arrow, because this is the real distance which the interacting field had to pass. Because the forces of interaction depend on the distance of propagation, the exact consideration with finite propagation speed of the interaction leads us to a force different from the results of the simple approximation under static consideration. The force of gravitation as well as the electrostatic force as well as magnetic forces decrease with the square of the distance between both interacting partners. For such type of forces, an exact consideration will lead to our two bodies approaching to each other to reduced interaction forces in comparison to the static approximation. The opposite case is seen when the partners of interaction are moving away from each other. When the field of interaction of partner number 1, this is the red arrow, is moving to the right side, partner number 1 runs to the left side. At the moment tc, the static approximation of infinite propagation speed of the interaction leads to a distance of interaction according to the long green arrow, whereas the exact dynamic consideration leads to a distance of interaction according to the short blue arrow. In this case, the fact that the partners are moving away from each other enhances the forces of interaction. The second example, which we want to regard, allows motions of the partners of interactions into arbitrary directions, not necessarily parallel to each other. This makes us understand the importance of the considerations, taking the propagation speed of the interactions into account. The very simplest case within this example is the static case, where the partners of interaction are in rest. I use the expression static for the approximation, neglecting the propagation speed of the interactions. This simple approximation is the contents of Newton's law of gravitation, and it is the same approximation within Coulomb's law. A more precise consideration is given by Nikolai Kozyrev, who did not speak about vacuum energy as a property of space, but as a property of time, and he called it time energy. I am not going to discuss the details of Kozyrev's model here, but I want to mention one of his main results. The vectors of the forces of interaction do not necessarily point to each other, but they can be parallel to each other. The third case, which I explained here, is the most universal description, which can lead to the consequence of vectors of interaction even not parallel to each other. This finally gives us the possibility to convert vacuum energy. It should be emphasized that the first two cases are special cases of my consideration. In order to illustrate my conception, I invite you to look to the partners of interaction which produce fields with spherical symmetry. This means the field of interaction is emitted homogeneously into all directions. Now let us regard the example that the left partner moves straight upward and the right partner moves straight downward, and they do this with different absolute values of their speed. And please keep the red arrows for one part of the field of interaction into remembrance, which we will need later. Now let some time pass by and have a look to the situation a little bit later. The left partner has moved downward and the right partner upward. The red arrows indicating a special part of the field of interaction already did some way away from their source, but they did not yet reach the other partner of interaction. If we regard the situation even more later, we come to the moment when both red arrows arrive at their partners. Now we can see which force of interaction each partner experiences. Obviously, the forces do not point into the directions at which the partners are at this moment. But the force of interaction depends not only on the position of the partners, like it would be in a static consideration. Also, the trajectories of the partners have to be taken into account. We now want to think whether we can find a way to use our dynamic laws of interaction, taking the finite speed of propagation of the interaction into account, to help us to convert vacuum energy into interaction energy. Nikola Tesla once said, with regard to the construction of vacuum energy converters, it is not difficult. You just have to know exactly how to build it. And this is what is going on. Indeed, it is not difficult. You just have to take two electrically charged bodies or two magnets and connect them with a spring. If the both bodies move towards each other, we have the reduction of Coulomb forces or magnet forces as explained above. But if both bodies move away from each other, the Coulomb forces or magnet forces are enhanced in comparison with a static consideration that is not taking the propagation of the interaction fields into account. The trick is now, if we strain the spring and then allow an oscillation, it would not be harmonic due to the magnetic or electrostatic forces. This is even the case under static consideration, but the dynamic consideration would lead us to an additional possibility. We can adjust the stiffness of the spring in such a way that the speed of motion of the bodies corresponds to the speed of motion of the interaction fields, so that both of them come into resonance in the same moment. The adjustment has to be done very carefully and very precisely, and then we can achieve the situation that during those moments when the spring force is attractive, the attractive magnet force is enhanced, and during those moments when the spring force is repulsive, the attractive magnet force is reduced. The magnet force always has the same direction. By this trick it is possible to enhance the amplitude of the oscillation without giving classical energy into the system. The energy within the oscillating system permanently increases, being supplied from the vacuum energy. In the static consideration, without the finite propagation speed of the electric or magnetic field, the deflection would be periodically. In the plot we have to imagine the bodies moving along the blue and red curve, whereas the spring goes straight upward between the both bodies. Obviously the static classical approximation follows the conservation of classical energy perfectly. In the dynamic consideration, taking the finite propagation speed of the electric and magnetic field into account, the deflection can gain energy from the vacuum and enhance the amplitude without being supplied with classical energy. When the oscillating bodies reach a speed which interferes with the speed of interaction in some special way, the gain of vacuum energy can run into saturation. The point is that energy conservation has to take vacuum energy into account. In the opposite way around, the dynamic consideration can have the consequence that classical mechanical energy of the oscillation is converted into vacuum energy. The decrease of the amplitude in our numerical example can be achieved without any mechanical friction. This is not the mode of operation which is useful for the engine, but it is only a demonstration that the conversion of energy between vacuum and classical energy can be done in both directions arbitrarily as we like it. The computation method, which I call DFEM, is an abbreviation for Dynamic Finite Element Method. Due to the dynamic behavior of the interaction fields, I demonstrated in several publications how it works. It goes back to a coupled system of inhomogeneous differential equations which are of second order for our oscillations. The solution cannot be done analytically but only numerically by iteration. The problem with regard to the conversion of vacuum energy is that the speed of propagation of the interaction is much larger than the speed of the mechanical motion of the bodies, so that the mechanical parameters and the magnetical parameters can hardly be adjusted to each other. Thus the converted power is only in the range of picowatts. Obviously the system needs some changes. Obviously we need additional inventions and ideas. The very first good idea comes from the control of the speed of propagation of the interaction. When we take electrically charged spheres and connect them not only with a spring but also with a conductive wire, which can be formed as a coil, we can make the electrical charge oscillate between the both bodies. For the theoretical simulation this is not very complicated because the both bodies just are plates of a capacitor. And the capacitor plates are connected with a coil. This is an oscillation circuit. The computation of this LC oscillation circuit is a topic of lectures for beginner students. You see, it is not complicated. But now there is the complication. The capacity is not constant because the capacitor plates oscillate relatively to each other. This makes the coefficients of the differential equations for the description of the system time dependent. But only the mathematical treatment will become complicated. The conversion of vacuum energy will become possible. In the moment the coefficients of the differential equations become time dependent, we get the possibility to convert vacuum energy. But of course time dependent coefficients are much too complicated to explain it to students within some lectures. I want to summarize my results as following. The mechanical connection between the capacitor plates allows the conversion of vacuum energy. For the practical operation, the adjustment of the mechanical resonance to the electrical resonance is not very easy, but both resonances must coincide for proper operation to convert vacuum energy. For this reason I gave the system the name EMDR converter, which is an abbreviation for electromechanical double resonance converter. Just because two resonances have to be adjusted to each other, an electrical one and a mechanical one. The control of the propagation speed of the interaction is done by the means of the electrical oscillation circuit. The enhancement of the amplitude without classical energy supply is very clear in this example. But we see that the electrical amplitude is enhanced much more than the mechanical amplitude. The problem is the stiffness of the spring connecting the capacitor plates. This restricts the conversion of vacuum energy to the nanowatt range, maximum to very few microwatts, depending on the dimensions of the system parameter. At first I thought that I could solve the problem by finding a new method to extract energy from the electrical circuit, but I found that this was not practicable. The problem really comes from the limitation of the mechanical oscillation. The solution of the problem is astonishingly easy. If something is disturbing, just remove it. Our disturbing component is the spring, so take away the spring. But we have to adapt the other parts of the system. If we remove the spring within the capacitor, we will no longer have the variable capacity. This means we lose the time dependency of the coefficients in the differential equation. And we need this in order to convert vacuum energy. Removing the disturbing spring makes it necessary to find some other component to realize the variability of the coefficients in the differential equation system. There are not many components which could do this job. Our whole setup consists only of one capacitor and one coil. We cannot use the capacitor, so what? We have to use the coil. This is the only choice. The question is, how can we influence the coil? The variability of the coil can be made with the use of a magnet rotating inside the coil. Differently from the oscillation, the rotation does not need a spring, and the frequency of the rotation can be changed more easily than the frequency of an oscillation. Nevertheless, the rotation is nothing more than two superposed oscillations in more than one dimension, reminding to Lissajous figures. The enhancement of the amplitude without classical energy input is now very efficient. We start the rotation with an initial value coming from a starter motor, and then we disconnect the starter motor and allow the system to increase the amplitude by a loan supplied from the energy of the vacuum. The plot demonstrates how the electrical current increases within the very first second of operation of the zero-point energy converter. Please do not forget that all diagrams from the EMDR converters present only theoretical results. I do not have a possibility to build a prototype of an EMDR converter because I do not have the infrastructure to begin such a work at all. Although I am an experimentalist, I do not have any technical equipment and no time for experiments. By the way, the quick alteration of the electrical current shows that we have a very special AC generator. If your computer screen has high resolution, and I would plot the diagrams with the same resolution, we might see the quick oscillation of the current. But not only the electrical energy within the system increases during operation, but also the mechanical speed of operation. You can see this when you regard the angular velocity of the rotating magnet. Very impressive is the enhancement of the energy sum of the total classical energy within the system. The coil within which the magnet rotates has a diameter of 9 cm and a height of 6.8 cm. This is not very much if we know that the converted power is in the range of 1 kilowatt. This shows that the power density of the vacuum energy motor is quite good. Thus we can say this is now a design for practical applications. Furthermore, the setup is developed with realizable system parameters, so that it is indeed possible to build up a prototype. It is not important that I do not have the possibility to realize this prototype. Important is only that somebody will do it, because mankind needs vacuum to survive on this earth. In order to enhance the precision of the computer simulation, I further developed my DFEM algorithm in a way that it allows to simulate every vacuum motor by principle. The simulation which I will now show is a different geometry than the geometry before. I gave a source code and demonstrated its use in scientific publications, and the demonstration with an example of a magnet converter as shown in the picture. A cylindrical bar magnet is rotating between two coils, but one coil can be left away for the purpose of making the design most easy. In meantime, I did my theoretical development so far that I have the complete theory of vacuum energy conversion. It is published in scientific articles. On the basis of this theory, it is possible to simulate arbitrary ZPE converters, zero-point energy converters, and to calculate how they can be used for the conversion of zero-point energy. The algorithm which I developed on the basis of my theory allows not only to simulate converters with motions, but as well motionless converters. I also simulated my EMDR converter with a DFEM algorithm. The picture seen now shows a bar magnet with a length of 10 centimeters rotating inside a coil of 9 windings. The setup has practical reasons, because 10 centimeters long magnets can be bought rather inexpensive. The cross-section of the coil with 10 to 12 centimeters is appropriate for this magnet. The copper wire is drawn in blue color with a material thickness of 10 mm because Ohm's resistance has to be really small and the electrical current is rather large. To use 9 windings only will restrict the voltage amplitude to about 200 volts and the current to about 60 amperes. Therefore, the copper wire is thick enough. Some of the technical data of the system are: capacitor 101.7 microfarad to be adjusted extremely precisely. Load resistor 640 milliohms. Rotation to be started with 30,000 rounds per minute, but in operation 30,100 rounds per minute. Electrical power extraction 52 watts, mechanical power extraction 528 watts. The complete set of the system parameter consists of several dozens of values which are written in scientific publications. One of the results of the DFAM simulation is the fact that the EMDR magnet converter needs mechanical load in order to become able to convert vacuum energy. Without mechanical load, no conversion of vacuum energy. Without mechanical load, the system will run into saturation at a constant speed of rotation, and the speed is kept even under mechanical load, so that the converter power is just as much as the mechanical load requires. Only if the mechanical load would be too large, the system would be damped down to standstill. The reason for the necessity of a mechanical load is that the system needs a phase shift between the electrical oscillation and the mechanical rotation. This phase shift is necessary that the magnetic field produced by the coil will accelerate the rotating magnet just in the moment when the coil's field is especially strong, but it will decelerate the rotating magnet in these moments when the coil's field is especially weak. This explanation cannot be understood without graphical help. Thus I prepared a series of photos to make the explanation understandable. The oscillation within the electrical circuit, consisting of one capacitor and one coil, makes the electrical energy within the electrical circuit move back and forth between the magnetic field and the electrostatic field. The magnetic field in the coil and the electrostatic field in the capacitor. This is done exactly 2 times per each period of oscillation because the capacitor plates are charged alternating positively and negatively, and the magnetic field of the coil is alternating north and south. In those moments when the field energy is within the coil, the magnet is accelerated remarkably, but in those moments when the field energy is within the capacitor, there is no magnetic field acting on the magnet. Let us first regard the case of optimum beneficial phase shift, which causes a strong rotation. We can understand this operation when we regard a series of 8 moments following after each other. They are shown in pictures with numbers from 1 to 8. The capacitor is drawn in purple color, and the electrical charge on the capacitor plates is marked with positive and negative algebraic signs. We will use the convention to draw the more algebraic signs, the more charge we have in the capacitor. If the charge is flowing within the LC circuit, a black arrow shows the direction of the flux, where the charge has to flow through the coil drawn in blue color. This causes an electric current which produces a magnetic field which is symbolized with letters in red and green, N and S. The number of letters again represent the field strength. Now let us begin our explanation with picture number 1. At the moment T1, the capacitor still contains a little bit of electrical charge, but another part of the electrical charge is flowing through the coil, producing a slight magnetic field. Following the polarity of the magnetic field of the coil and the permanent magnet, there is a torque accelerating the permanent magnet clockwise. In picture number 2, the capacitor is completely discharged, so that the field energy is completely in the coil. The magnetic field has its maximum now. Thus the torque accelerating the permanent magnet is rather strong now, with an acceleration also clockwise. In picture number 3, the magnetic field begins to decrease, but due to the orientation of the permanent magnet there is no torque and the acceleration of the rotation is 0. If the magnetic field would not be decreased down to 0, in picture number 4 there would be a torque to decelerate the rotation of the permanent magnet. But this does not happen because the field energy is completely within the capacitor. The fact that the coil has no magnetic field now can be seen from the missing north and south at the coil. In picture number 4 the capacitor was charged maximal. Now in picture 5 we can see that the capacitor already begins to discharge a little bit. The situation reminds to picture number 1, but the electrical current is flowing into the opposite direction. Thus the magnetic field of the coil has the opposite direction than in picture number 1. Same as the rotating permanent magnet has the opposite orientation than in picture number 1. Consequently, the permanent magnet is also accelerated clockwise now. In picture number 5, the magnetic field of the coil is increasing and it comes to its maximum in picture number 6. Picture number 6 corresponds to picture number 2, and due to the orientations of the magnet and the field, the acceleration torque is clockwise now. Picture number 7 corresponds to picture number 3. There is still a small magnetic field in the coil, but it makes no torque due to the orientation of the magnet. In analogy to picture number 4, we see picture number 8. There is no decelerating torque because the electrical charge is now completely in the capacitor and no charge is in the coil. The complete series of moments now will come back to picture number 1 after picture number 8. So the operation continues cyclically. The acceleration of the rotation of the permanent magnet will be continued as long as the phase difference between the position of the magnet and the oscillating fields in the LC oscillating circuit is existing. The opposite way around is the operation without any conservation of vacuum energy. This will happen when the phase shift has a disadvantageous value. We want to regard this now. Please start with picture number 1, where the permanent magnet experiences a slight acceleration clockwise, but this acceleration is compensated in picture number 3 exactly. Furthermore, we see picture number 2 without any acceleration because the orientation of the magnet does not allow acceleration, and picture number 4 without any acceleration because the coil does not produce any magnetic field at this moment. Finally, we see that the total sum of the acceleration from pictures 1 to 4 is absolutely 0. There is no acceleration in sum at all. The same argumentation as we had over pictures number 1 to 4 comes again from the pictures number 5 to 8. Finally, we conclude that this operation does not provide any accelerating torque. The magnet has the same frequency and phase as the electrical LC circuit. And now we have the situation that the magnet cannot overtake, because the phase shift between magnet and LC oscillation is 0. In this operation there is no conversion of vacuum energy. The fact that the rotating magnet can never overtake the electrical oscillation, even not without mechanical load, gives us the security that the operation will not run away, because it is impossible that the magnet comes into a too fast rotation. As soon as the magnet would enhance its speed of rotation, the phase shift would disappear and the rotating magnet will no longer be accelerated. The optimum phase shift for a maximum power being extracted from the vacuum energy is 45 degrees. But this will not be kept constant if the EMDR converter is loaded only electrically. A phase shift can only be maintained by the application of mechanical load. The fact that the system indeed converts vacuum energy and the classical energy is not constant can be proven most easily by setting up and solving the system of differential equations. Because we have time-dependent coefficients, a gain of amplitude is possible without supply of classical energy. This means that the system can only be understood as soon as the energy conservation is calculated, taking classical energy and vacuum energy both into account. The mathematical background with all the differential equations is published in scientific articles. Here we only speak about results which are understandable also for non-physicists and laypersons. The starting procedure of the EMDR vacuum energy converter is done by bringing the rotating permanent magnet into an initial rotation. From there, some electrical voltage is induced into the coil so that some energy is extracted from the rotation and inserted into the LC circuit. From there on, the system is self-running, without classical energy being necessary. This picture shows the angular velocity of the rotation of the permanent magnet with the speed of the rotation. At the beginning we see how the electrical LC circuit extracts energy from the rotation of the magnet, but soon the conversion of vacuum energy will bring the system into stable rotation. As can be seen, the starter motor has to initialize the motion with a speed of rotation not far below the operational speed of rotation. The conversion of vacuum energy is efficient enough that even after a bit more than half of a rotation the magnet is faster than at the beginning, and additionally it gave some energy into the LC circuit. The operation with constant speed of rotation is observed under constant mechanical load. A control of the mechanical load allows the rotor to come into stable operation very soon. If we plot the value of the electrical charge in the capacitor, which is proportional to the voltage over the capacitor, we see the AC voltage with the frequency of the mechanical rotation. This frequency is so high that we can see only the envelope of the curve. But if we plot the time scale with high resolution and with a zoom, we see a clear AC shape. A charge amplitude of 0.02 Coulomb at a capacitor of about 100 microfarads leads us to a voltage of about 200 volts over the capacitor. By the way, the voltage over the coil has a rather similar amplitude. The current in the coil has an amplitude of about 60 amperes. The frequency is the same as the frequency of the rotating magnet, which is a bit more than 500 Hz. Obviously, the transient part of the operation is only a short duration, so that the system goes rather fast into the stable mode of operation. The total energy within the system, as the sum of the electrical energy and of the energy of rotation of the magnet, represents the transient part of the operation very clearly, as we know it from the angular velocity. The fact that the speed of rotation goes to a constant value has its reason in the fact that we permanently extract mechanical and electrical energy from the system. In the stable operation, the extracted mechanical and electrical power is constant during time, as well the amount of vacuum energy being converted per time interval. With the system presented here, containing a magnet with a length of 10 centimeters and a coil of a geometrical dimension compatible to the magnet's length, the DFEM computation example makes us expect a mechanical power extraction of about 530 watts and an electrical power extraction of about 50 watts. Altogether, we see the concept of a vacuum energy motor with a diameter of about 10 centimeters and a power conversion of a bit less than 600 watts. For the motor is self-running, the power is completely extracted from the quantum vacuum. In principle, it should be possible now to manufacture an EMDR converter as presented here, if the infrastructure and the conditions are available for this work, such as, for instance, the necessary time to work, a mechanical workshop, tools to manufacture electronic components, skilled co-workers for mechanical and electronical work, an equipped laboratory with measuring devices and facilities for research, co-worker support for practical research work, a budget for the necessary material. For I do not have any of these components, I am not in the situation to build a prototype of the MDR vacuum energy converter. Of this reason I can only hope that some of my colleagues will bring this theoretical concept into practice. Therefore I will now speak about some practical hints to make the work understandable for my colleagues. By the way, I should mention that I published in scientific articles all details and many further facts, as well as technical drawings how to build the system. One of the problems of the practical manufacturing of a prototype is the high speed of rotation. In our example here, we have a rotating bar magnet with 30,100 rounds per minute. For all components beside the coil and the magnets must be non-ferromagnetic and non-conductive. It is not trivial to organize an appropriate bearing. A strong reduction of the speed of rotation can be achieved if the bar magnet is replaced by an array of many single magnets, so that each mechanical turn causes many oscillations of the magnetic pole close to the coil. This gives us the possibility to have the mechanical frequency much lower than the electrical frequency of the LC circuit. A bar magnet has two changes of a pole, once north and once south, per each turn, but a ring of 40 magnets has 40 or 80 changes of poles per each turn, depending on the orientation of the single magnets. The speed of the mechanical rotation is reduced by the same factor, so that an electrical frequency of 30,100 rounds per minute would be in agreement with the mechanical frequency of 30,100 divided by 14. This is 752.5 rounds per minute only. This should solve the problem of the high frequency rotation. The single magnets can be fixed with special units which allow a geometrical adjustment in the experiments. Details are also written in scientific publications. Now that I have shown concrete technical drawings to everybody, I hope very much that some colleagues who have the possibility will build a prototype. I don't have the time to give individual advice to anybody asking for technical or physical details. But I would be very glad if colleagues who have some results will let me know. I have worked on the fundamentals of physics, but I also made plans for technical construction of a vacuum energy motor. If there will not be any colleagues building a prototype on the vacuum converter, I will not feel guilty because of unclean energy supply will damage our Earth. I did my best, and I did it as good as I could do. So we can come to the result of the whole work. Mankind can utilize vacuum energy. A fundamental proof for the usability of vacuum energy is presented on university level. Working prototypes of vacuum energy motors already exist on our Earth. We have even heard of a sample with certificates of honorable institutes such as German TÜV or American Underwriter Laboratories. But these engines are still not ready for mass production. But it should be possible to get this last step of development for these engines as well as for mine. In order to find a way to handy and powerful vacuum energy motors, we developed a theory of vacuum energy conversion. On the basis of this theory, we developed the theoretical construction of a powerful vacuum energy motor. Furthermore, we took care that our construction, which we call EMDR converter, is not much more expensive than a normal electromotor, as you can buy it everywhere in the supermarket. Thus, the way into the utilization of zero-point energy of the quantum vacuum is visible. Vacuum energy is clean. It does not pollute the environment at all. It is free for everybody and it is inexhaustible. Its only disadvantage is that it is not expensive like classical conventional energy sources such as gas, oil or nuclear energy. Thus its exploration is not endorsed by the energy industry. Consequently, its exploration can only be done by independent researchers or by private investors. Only if a majority of people ask for the clean and free energy it will be possible to get enough support for scientists that its utilization can be made possible. If people do not ask for clean and free energy, nobody will get it. The market only produces what people are asking for. By the way, for those branches in industry who have to buy energy, vacuum energy will be a tremendous push for economical growth. This is the main part of industry. So we can conclude that vacuum energy will bring many new plants and many new working places. This is also a realistic goal. Everybody will have work if vacuum energy will come to be breakthrough technology. And there is another goal. In Africa, water could be pumped with free energy motors all over the country. There would not be any hunger any further, and people would have enough water everywhere. Thus, the way towards the sustainment of our planet is much easier than many people can imagine today. Tell your friends what you have seen now. Spread the knowledge of free energy and clean energy everywhere. When a majority of people will know about free and clean energy from the vacuum, we will get it. And then we will not have to pay for electricity or gasoline any further, and not for heating our rooms. Then pollution of our environment will become a topic of history as well as hunger.